Ionic bonding, part 1. Hello class, I hope you are doing fine. Before we begin, please ensure you have the following relevant materials. Note 6a, Ionic bonding, your stationery including highlighters, and a copy of the periodic table. Pause the video here to find these materials. Once ready, we can move on. As we go through the slides, the top will always show the page number and subtopic in your notes. And if you see any underlined words, please fill them in your notes. If you see any highlighted words, you may choose to highlight them. And if you see any scribbles or red words, please add them on to your notes. Sounds good? Let's go. Before we begin on the new topic, let us recap a previous topic on atomic structure. Okay, we see here the planetary model of an atom, in this case the aluminium atom. Alright, the center of the atom has protons and neutrons in the nucleus. And you can see electrons in shells orbiting around the nucleus. We can represent the atom using this symbol in writing, Al with 27 on top and 13 below. Or you can also find a similar representation in the periodic table as shown here. Okay, this kind of representations will tell you the number of protons, neutrons, and electrons in the aluminium atom. Okay, so what do you remember from this topic? What does each number represent? Okay, if you look at the smaller number, okay, it is known as the proton or atomic number. And in an atom, the number of protons is equal to the number of electrons. So in this case, aluminum will have 13 protons and 13 electrons. The bigger number is known as the nucleon number or the mass number. Okay, the nucleon number or mass number is the number of protons plus the number of neutrons. Okay, something to take note, nucleon number is related to the nucleus. Okay, since the nucleus contains protons and neutrons, the nucleon number is the total number of protons plus the total number of neutrons. In this case, aluminum have a total number of 27 protons and neutrons. So, for this atom, how many protons, neutrons, and electrons are there? Okay, so the easiest one would be the number of protons. We just look at the smaller number. In this case, there are 13 protons. And since it is an atom, it will also have 13 electrons because the number of protons is equal to the number of electrons. But how many neutrons are there? Okay, this time we need to use the nucleon number. Since there is a total of 27 protons and neutrons, and there are 13 protons, so it makes sense that there are 14 neutrons. Right, so this is a recap of what we have done previously. Right, another recap, electronic configuration. Looking at the same planetary model of the aluminium atom again, we can see that the electrons are arranged in shells around the nucleus. Do you remember how do you arrange the number of electrons into the shells? Okay, for the first 20 elements, the maximum number of electrons for the first, second, and third shells are 2, 8, and 8 respectively. Alright, I like to call this the 2-8-8 rule. Okay, that means the first shell can only have 2 electrons, the second shell can only have 8 electrons, and the third shell can only have 8 electrons also. Please take note, this only applies for the first 20 elements. Since aluminium has a proton number of 13, it will thus have 13 electrons. So what is the electronic configuration of the aluminium atom? How do we arrange the electrons into the shells? Alright, so the first shell can only take 2, so it will be 2. Now I have 11 electrons left over to arrange. Can I put all 11 electrons in the second shell? No, I cannot, because the second shell can only have 8. So the second shell has 8. Now I've arranged a total of 10 electrons. So I have 3 electrons left over, and they can be placed in the last shell. So the electronic configuration of aluminum atom is 283, as you can see from the model on the left. Right, so that was a recap of a previous topic. We shall now move on to the new topic. Refer to page 1 of your notes under recap valence electrons. Okay, I would like you to add the words and group number to the topic. Alright, so the valence shell of an atom refers to the outermost electron shell of the atom. And the valence electrons are the electrons that occupy this valence shell. Okay, please highlight the following words. Okay, so please take note the difference. When I talk about the valence shell, it refers to the outermost electron shell. And when I talk about valence electrons, it's the electrons in this outermost shell. So what is the electronic configuration for the atom Mg2412? Alright, this is the magnesium atom. So as we have covered just now, what number do we look at to find out how many electrons are there in the atom? Alright, we look at the smaller number, because in an atom, the number of protons is equal to the number of electrons, and the smaller number is the proton number. So magnesium has 12 electrons. So what is the electronic configuration for magnesium? Okay, the first shell can only take 2. So now I have 10 electrons left to arrange. Can I put all 10 in the second shell? Okay, no. Similarly, second shell can only take 8. Yeah, so after I've arranged 10 electrons to 8, how many electrons are left over? And that is 2. Right, so write down the electronic configuration for magnesium as 282. And if you draw it out, this is what it will look like. Okay, magnesium nucleus surrounded by the first shell with 2 electrons, followed by the second shell with 8, and the last shell with 2. Alright, so how many valence electrons does magnesium have? Okay, looking at the outermost shell, okay, magnesium has 2 valence electrons. Please write that down. Okay, I would also like you to add on, okay, because magnesium has 2 valence electrons, it will belong to group 2 of the periodic table. Please remember, the number of valence electrons corresponds to the group number of the periodic table. So write down these notes also. So example, magnesium has 2 valence electrons, so it will be in group 2 of the periodic table. And similarly, aluminum just now has 3 valence electrons, so it will have so it will be in the group 3 of the periodic table. Alright, so an important concept for you to learn in this topic is what happens to the valence electrons when atoms react. Okay, atoms will lose, gain, or share valence electrons when they react. So in a reaction, only the valence electrons are affected. Next, we shall discuss about the noble gases and their stability. Noble gases are found in group 0 of the periodic table. Okay, that is the rightmost part of the periodic table. As you can see here, we have helium, neon, argon, krypton, xenon, and radon. Okay, noble gases exist as individual atoms and do not combine with other atoms or form compounds. This is because noble gases are unreactive and stable. Noble gases are stable because of fully filled valence shells. Okay, please write this down. A very important concept. So let's take a look at three noble gases. Okay, we have helium with proton number 2, neon with proton number 10, and argon with proton number 18. Okay, the electronic configuration of helium is 2. Okay, and since it has since it has two valence electrons in the outermost shell, okay, we give it a designation of a duplet configuration. Neon, on the other hand, will have an electronic configuration of 2,8. Since its valence shell has 8 electrons, we give it the name of a octet configuration. Okay, and this is very similar for argon, which is 288, and it also has a octet configuration. Right, copy this down in your notes. All right, so I reiterate. Noble gases are stable because their valence shells are fully filled. So very, very important. Atoms gain, lose, or share valence electrons when they react so that they can achieve a stable noble gas electronic configuration. Right, so let's look at magnesium. Right, the electronic configuration is 282. Right, so in order for magnesium to achieve a stable noble gas electronic configuration when it reacts, it can either become 288 by gaining 6 electrons, or can become 28 by losing 2 electrons. Okay, so once again, when magnesium atom reacts or any other atom reacts, they are trying to achieve a stable noble gas electronic configuration. Since magnesium has 282, it can either become 288 by gaining 6 electrons or 28 by losing 2 electrons. Which one do you think is easier, gaining 6 electrons or losing 2 electrons? Right, that's right. Losing 2 electrons will be easier. So when magnesium atom reacts, okay, it will lose 2 electrons to form the magnesium ion. Okay, and since it lost 2 electrons, we'll represent the magnesium ion as Mg2+. Okay, turn to the next page. All right, you may write these extra notes. Okay, but the table asks you to draw. So for the magnesium atom, okay, draw 282. Okay, and as we have discussed just now, okay, it will lose 2 electrons, okay, to form the magnesium ion, which is represented by this diagram, 2,8. And since it will have a 2 plus charge, please draw brackets around the diagram and write 2 plus. Okay, once done, let's look at the next example, which is nitrogen. Okay, so nitrogen, electronic configuration of nitrogen. Okay, we look at the proton number 7, so it will be 2, 5. So for nitrogen to become stable noble gas electronic configuration, when it reacts, it can either become 2,8 by gaining 3 electrons, or it can become 2 by losing 5 electrons. Okay, so which one is easier, gaining 3 electrons or losing 5 electrons? Okay, it is easier to gain 3 electrons than losing 5 electrons. So in this case, the electronic configuration for the nitrite ion would be 2,8. And since it gained 3 electrons, we can represent the ion by writing N with 3 negative charge. Okay, something to take note. When an atom becomes a negatively charged ion, the name changes slightly. So from nitrogen, it becomes nitrite ion. Right, so back to the table. Okay, draw the electronic configuration of the nitrogen atom 2,5, and as previously discussed, it will gain 3 electrons to form the nitride ion. So draw 2,8 and bracket with the charge of 3 negative or 3 minus. Okay, once done, okay, your drawing should look like this. Okay, I'm sure you can draw much better than me. So key points. Atoms of metals tend to lose electrons to form positively charged ions or cations. Highlight this key fact. Metals tend to lose electrons. On the other hand, atoms of nonmetals tend to gain electrons to form negatively charged ions or anions. Highlight. Okay, so how do I know whether an atom is a metal or an atom is a non-metal? Okay, you will use the periodic table, and metals tend to be in group 1 to 3, while non-metals tend to be in group 4 to 7. Alright, the noble gases are also non-metals, but I did not include them for this case because noble gases will not form ions. They are already stable. Okay, so I repeat, metals, which are usually found in group 1 to 3, will tend to lose electrons to form positive ions, and non-metals, which tend to be in group 4 to 7, will tend to gain electrons to form negative ions. Alright, that's it for this part. Please try the questions in quiz time. Okay, and I will see you guys next time. Take care.